Good morning. I am Dr.D.Sathya, working as assistant professor in Department of Chemistry, SNS College of Engineering. In last class, we had discussed about the introduction of electrochemistry. So, in this session, we are going to discuss about the electrochemical cell. So, electrochemical cell is a device that can generate electric energy from the chemical reactions occurring. Use of electrical energy is supplied to the facilitate the chemical reaction in it. So these devices are capable to converting chemical energy to electrical energy. A common example of an electrochemical cell is the standard 1.5 volt cell, which is used to power many electrical appliances such as TV remotes and clocks. So these such cells capable to generating electric current from the chemical cell occurring them, it's called it the different type of the cell. It's called it galvanic cell. The two types of electrochemical cell, galvanic cell is the spontaneous chemical reaction, it generate the electric current. The second one is electrolytic cell. It's an electric current drives a non-spontaneous in the chemical reaction. So what is meant by galvanic cells? Galvanic cells is a very important cell in electrochemical cell. Its cell which chemical energy is converted into the electrical energy. This cell consists of two half cells. One is the anode half cell and the other one is the cathode half cell. So in anode part we are using some zinc rod, for example, where zinc rod in dipped into zinc sulfate solution, and other half the copper rod, it's dipped into copper sulfate solutions. So here the zinc act as a anode and other part the copper act as a cathode. At the anodic half cell oxidation takes place, at the cathodic half cell the reduction takes place. The following reactions takes place in the cell. If zinc is the loss of electrons to get zinc 2 plus, so the oxidation occurs. The oxidation means the loss of electrons. At the cathode side, the copper gain of 2 electrons, that means the reduction occurs. In oxidation, oxidation occurs in one half of the cell, it's called at the anode. When copper gain the electron, it's called as reduction. That part is called as cathode. So the movement of electrons from zinc to copper produces the current in a circuit. The overall cell reaction is copper plus 2 plus. It's connect with zinc to form loss of electron in zinc and gain of electron in copper. So the galvanic cell can be represented by zinc sulfate and copper sulfate solution with copper electrode. So these are the difference between electrochemical cell and electrolytic cell. The electrochemical cell in which the produces the electricity as well as the chemical reaction, it's called it the electrochemical cell. In electrolytic cell in which electrical energy is converted into chemical energy. In anode, the chemical cell in the negative electrode, the anode of the electrolytic cell is positive electrode. In cathode, in electrochemical cell is positive, in electrolytic cell is the negative. The current direction, the electrochemical cell, the current flows from cell to the external circuit. In electrolytic cell, the current flows from the external circuit to the cell. So the chemical reaction in electrochemical cell, the spontaneous chemical reaction occurs to produce the electricity. In electrolytic cell, the non-spontaneous reaction takes place. So the construction of the electrochemical cell is in the form of two half cells. In electrolytic cell, the complete cell is assembled in a single cell container. For example, in zinc sulfate and copper sulfate used in this electrochemical cell, two half cells. In electrolytic cell, in one beaker we are used in single container with two electrodes. The energy conversion in electrochemical cell, chemical to electrical, in electrolytic, electrical energy to chemical. So the need for external power source in electrochemical cell that does not require the external source to supply. In electrolytic cell, we required some power in the electrolytic cell. The movement of electrons in electrolytic cell, the flow from anode to cathode through the external circuit. In electrolytic, the external battery supplies the electrolysis to go through the cathode and through the anode. In electrochemical cell used as a source of electricity such as the battery, in electrolytic cells are used in electrolysis of the compounds. Reversible and irreversible cell. A cell is said to be a reversible if it satisfies the following these conditions. If an EMF exactly equal to the cell applied from the external source, the chemical reaction takes place in the cell will stop. That is, no current flows. If the external EMF is slightly greater than the actual EMF of the cell applied, so the current will begin to flow the opposite direction. If the external EMF is slightly lower than the current, the EMF is applied to the very small amount of the current will flow, the corresponding to very small amount of the chemical changes taking place in the cell. Let us consider the Daniell cell as a reversible cell. Here the copper with the zinc, copper gets loss of electrons to get zinc neutral, and copper get loss of electrons to give copper 2 plus, and zinc 2 plus lost the electrons to give zinc. When EMF is slightly lower than, the zinc is converted into Zn2 plus and copper 2 plus is converted into copper. In irreversible cell, the zinc is contact with sulfuric acid, the zinc sulfate is formed. Here the zinc dissolves one electrode and the hydrogen is evolved at the another electrode. Whether the external EMF is greater than the silver is dissolved at one electrode and hydrogen is evolved at the another electrode. The silver contact with the sulfuric acid to give silver sulfate and hydrogen is evolved. So the electromotive force, that means EMF. The EMF in the different